We have the atmosphere, remember, the hydrosphere, the biosphere, and the lithosphere. And I will go through each in detail. But before that, we have this slide which talks about the systems I just mentioned and how they are interacting with each other. So all these subsystems are extremely open and they are very, very dynamic. It exchanges matter, energy, and they will recycle and turn into a different form a lot of the times. So we're gonna start with the atmosphere. This picture here shows the atmosphere, and you can see it has different layers, but for this class we don't really need to know all those layers. What I really want you to know that the atmosphere is only 0.01% of the Earth mass, and obviously that's because it's gas. When you look at gas and compare it to rock, biosphere, even the hydrosphere, everything is more dense than the gas. So it's less than 0.01% of the Earth mass. It has very strong influence on the Earth evolution. You know that we would not be here without atmosphere. Life couldn't have started and evolved without the atmosphere. And it is circulating all the time. You know, we have all these horrible storms and air movement, and this circulation is powered by the heat. That's what makes the air move up. And of course the gravity, which makes it move back down. So this is also very important that you have to know that the composition is very unique in our solar system, very unique. And even if I woke you up from your best sleep, you were doing something really cool and I came there and asked the question suddenly, you still have to know that the composition is 78% nitrogen, 21% oxygen, and if you add those two together, 78 plus that 21, how much is that? Yes, it's 99%. So we hear so much about CO2. Now you know that CO2 cannot be more than 1%. Actually, it's less. So you can see that the CO2 is minor. It's like right today, it's about 400 ppm. What is ppm? I have to write it under here, ppm. So ppm is equal parts per million. So that just means that if you have a million particle, then if it's 400 ppm, that means that 400 of those million particles is carbon dioxide. So you see it's very, very minor. Most of the 1% is water vapor and argon. So a lot of different kind of rocks, but mostly the limestone will actually controls the amount of CO2 in the atmosphere, because as the limestone is forming, it is able to trap a lot of CO2 away from the atmosphere. So the next one is the hydrosphere, and that is the total mass of water on or near the Earth's surface. As you know, it covers 71% of the Earth's surface. What do you think? Is it changing through time? Yes, if you said yes, you're right. Right now the sea level is moving up, so the 71% is actually increasing. And when you have colder climate, then a lot of water is being locked up into the ice, so therefore it's decreasing. So it's in a constant motion of going up and down, this percent. So you just know that today is 71% of the Earth's surface is covered with water. Now the bad news is that most of this water is in the ocean. So it's about 97, close to 98%, which is in the oceans. And around 97 something and around 2% is still in the glaciers and the groundwater lakes and streams. That's our fresh water. And so therefore you can see that the 98%, which is in the ocean, is not so good because it's all salt water. We cannot use it. And it also moderates the climate. And of course, it does a lot of erosion, so it shapes the Earth's surface. And the next one is the biosphere. And you know, the biosphere is all life on Earth. It's all the animals, plants on land, in the sea, and the air, of course. If you think about the life forms, it's easy to understand that the ones which we don't really see, but it's plentiful, just in our tummy there are millions of microorganisms. So those are the most common form of life. The life, actually, the biosphere forms a narrow zone near the Earth's surface. It could go up and down, of course, because in the oceans you got life, in the Earth you got life, and in the atmosphere we got life. So it's not only on the surface of the Earth, but all over, everywhere. Now, we do know about 1.6 million species, and more than 50% of it are insect, actually. It's crazy. The mammals are only 4,000 species, which is 0.025%, so it's much, much less than 1%. There might be 30 million more different species which there are, but we just don't know them. Most of them probably microorganisms, because we cannot really see them well. The local environments control their distribution, like, depending on the temperature, the pressure, and the chemistry of the environment. We know that there are a wide range of environmental conditions in which different animals and plants will live, and microorganisms, of course. Probably you haven't heard about it, but the biosphere is also a geologic force, and it's easy to understand because the current atmosphere is produced by the biosphere. Like at the beginning, we didn't have oxygen, and the microorganisms, the stromatolites, which are blue-green algae, produced the oxygen because they were photosynthesizing. Do you know what is photosynthesizing? It's when a plant-like organism sucks up the sunlight and the water, and it will make sugar, which is carbohydrate, plus oxygen. So that's how the oxygen actually forms. The ocean composition is influenced by the biosphere because all the clams and the corals, they are basically calcium carbonate precipitation from the ocean water. So therefore, they will change the atmospheric composition and the ocean composition as well. You know that the fossil fuels are all coming from living forms like the biosphere. And we have a fossil record which is also tells us a lot about the Earth's past environments. It's very interesting, this last thing, that if you look at all the species which we have on Earth today, they only account for 10% of all the known species throughout the geologic history. So you are part of that 10%. Like 90% of all the living things have already extinct, and so therefore they are not here anymore. And now we are at the very last part of this section, and that is the Earth internal structure. This is very important because to build the plate tectonics, which is the next module, you have to understand the solid Earth and its layers. We know that the Earth has layered structures, and these layers are defined by composition and physical properties. So this here is the drawing you have to do, and you can study it. And I already made a helping video about exactly how this should be learned, but this one here is okay. It's just that I made a more detailed movie about this. So just look out for it. I will put it in your module and you will find it and be able to look at it. Okay? So I will see you in the next module.